Linear motion with uniform acceleration and problems based on that will be the subject matter of today's discussion. Hello friends, you are watching channel Number Collage. This channel features concept videos on engineering mechanics in a simple and easy to understand language. A particle is projected vertically upwards from the ground. Suppose this is the ground and the particle is projected vertically upwards from the ground with an initial velocity of 9.81 meter per second. Its initial velocity u is 9.81 meter per second. We have to find the time required to reach the maximum height h. At maximum height, the final velocity v will be 0, and since the motion of the particle is in upward direction, acceleration will be minus g. In order to find the time required to reach the maximum height, we will use the first kinematic equation, which is v is equal to u plus at, that is u minus gt, replacing acceleration by acceleration due to gravity g. At maximum height, the final velocity v will be 0, so we get gt equals u, or t equals u by g. U is 9.81, g is 9.81. This will get cancelled and we get time required to reach the maximum height to be 1 second. The second question is, we have to find the maximum height reached. Now the particle starts from the ground in vertical direction, reaches the maximum height h, where its final velocity will be 0. Its initial velocity is given to be 9.81 meter per second. Since the motion is vertically upwards, its acceleration will be minus g. So, with the help of initial velocity, final velocity, and the acceleration due to gravity, we have to find the maximum height reached. So, we have to use the third kinematic equation, which is v squared is equal to u squared plus 2as. That will be u square minus 2gh, replacing this a by acceleration due to gravity g and displacement s by the maximum height reached. At maximum height, the final velocity v is 0, so this will be 0. That gives us 2gh equals u squared, that is h equals u squared by 2g. We will substitute the values. 9.81 multiplied by 9.81, which is u squared, divided by 2 multiplied by 9.81, which is the value of g. So this 9.81 cancels and 9.81 by 2 will be 4.905 meter. So this is the maximum height reached by the particle. In the third question, we have to find the velocity when it strikes the ground. Now the particle is moving downwards towards the ground. Its initial velocity u will be 0, and final velocity when it strikes the ground will be v, which we have to find out. And during the course of downward motion, it is covering distance equals h, which we have found 4.905 meter. And since the motion is downwards towards the earth, the acceleration will be plus g. With the help of initial velocity, acceleration, and height, we have to find the final velocity in the downward motion. We will use the third kinematic equation, which is v squared is equal to u squared plus 2as. We write u square plus 2gh, replacing this a by g and displacement s by the maximum height h. We will substitute the values. V square, the final velocity when the particle strikes the ground, equals its initial velocity, which is 0, plus 2 times 9.81 multiplied by the height 4.905, which will be 9.81 multiplied by 2 multiplied by 4.905 will be 9.81 again. So the final velocity when the particle strikes the ground v will be 9.81 meter per second. In the fourth question, we have to find the time required for coming down. Now the object is moving down, striking the ground with final velocity 9.81 meter per second. Its initial velocity had been 0, and since it's moving down, the value of acceleration will be plus g. So with the help of u, a and v, we have to find the time required t for coming down. So we will use the first kinematic equation, which is v is equal to u plus at, which will be u plus gt, replacing a by g. The final velocity when the particle strikes the ground is 9.81. Its initial velocity u is 0. Value of g is 9.81, and we have to find t. So this 9.81 cancels with this, and we are left with t equals 1 second. This is the same time which is required for the particle to move up and to cross the height h. So the time required for the particle to go up and to come down is the same in this case. Next problem is a small steel ball is shot vertically upwards from the top of a building 25-meter high with an initial velocity of 18 meter per second. In the first question, we have to find the time required for the ball to reach the maximum height. In the second problem, the situation is quite similar compared to the first one. Instead of from the ground, the ball has been thrown from the top of a building. So, this is the building, and from the top of it, this steel ball with initial velocity 18 meter per second is thrown upwards. Its acceleration will be minus g, and supposing it reaches the maximum height h after a time period t1. So we have to find this time after which it will reach the maximum height. When it reaches the maximum height, the velocity of the steel ball v will be 0. Now, with the help of initial velocity, final velocity, acceleration due to gravity, we will find the time period. For that, we will use the first kinematic equation, which is v equals u plus at, which will be u minus gt, replacing a by g. So v is 0, initial velocity u is 18, minus g is 9.81 and t, so 9.81 t will be 18. Therefore, t will be 18 by 9.81, which gives us time of 1.83 seconds. So the ball will take 1.83 seconds to reach the maximum height when it is thrown from the top of the building. In the second question, we have to find the maximum height to which the ball will reach. In order to find the maximum height to which this ball will reach, we have to make use of the final velocity 0, initial velocity u, which is 18, so as to find the maximum height h. For upward motion, we have a equals minus g. To find the maximum height, we have to use the third kinematic equation, which is v square is equal to u square plus 2as. That will be u square minus 2gh, replacing a by minus g and s by h. We will substitute the values. V square will be 0, u square will be 18 squared minus 2, g is 9.81 times height h. So 2 times 9.81 h will be 18 square. So h will be 18 squared by 2 multiplied by 9.81. That gives us the maximum height that the ball will reach to be 16.51 meter. The third question is compute the velocity with which it will strike the ground and the total time it was in motion. Now the ball has started moving down. Its initial velocity is 0, and since it's moving down, its acceleration will be plus g. Now, first it will cover the distance 16.51 meter, which is the maximum height it has reached from the top of the building, and the height of the building, which is 25 meter. So the total distance that the ball covers while moving down is capital H, which is 16.51 plus 25, which will be 41.51 meter. Suppose when the ball strikes the ground, its final velocity is v. In order to find the final velocity when it strikes the ground, we will use the third kinematic equation, which is v square is equal to u square plus 2as, which is u square plus 2gh. We will substitute the values. U is 0 plus 2 times g is 9.81 into 41.51, which is capital H. So that gives us v is equal to 28.54 meter per second. Now we have to find the time for which the ball was in motion. The ball initially was in motion when it was thrown from the top of the building so as to reach the maximum height here. So that time which we have found is 1.83 second. Let's call it t1. Now we have to find the time the ball takes to reach the ground. For that, we will use the first kinematic equation, which is v equals u plus at, that is u plus gt, replacing a by g. Now we will substitute the values. V is 28.54 equals u is 0 plus g 9.81 into, let the second time be t2. This gives us t2 equals 2.91 seconds. So the total time the ball was in motion, t equals t1, which is 1.83, and 2.91, that is 4.74 seconds. Next question is, a stone falls past a window of 2.45 meter height in half a second. Find the height from which the stone fell. Now we will draw the figure. So this is the window whose height is 2.45 meter. Suppose the stone falls from somewhere here, and since it is falling down, its acceleration will be plus g, its initial velocity u is 0. Suppose the stone covers distance from A to B, which is h, in time t, and after that it crosses the window and reaches the bottom of the window, which is C, by crossing the distance 2.45 meter. So we have to consider two motions of the stone. The first from A to B, and then from A to C. So first we will consider motion of the stone from A to B. Here the quantities that we have are the initial velocity u, acceleration due to gravity g, time t, and the height through which the ball falls is h. So we can use the second kinematic equation, which is S is equal to ut plus half at square. But since the ball is going down, it will be ut plus half gt square, replacing acceleration by g and replacing displacement by h. Since the initial velocity is 0, we get h equals half gt square. Next, we will consider motion of the ball from A to C. So from A to C, we will use second kinematic equation, which is S equals ut plus half gt square. In place of S, we have to use the height h plus the height of the window. So we write h plus 2.45 equals, since initial velocity u is 0, it will be 0 plus half g, the time required to cross the height h plus the time required to cross the height of the window 2.45 meter, which is given to be half. So here t will be t plus half, which is 0.5 whole square, which will be half g. Expanding the bracket, we get t square plus t plus 0.25, which will be half gt square plus half g multiplied by t plus 0.25. Since this h is half gt square, this half gt square cancels with this h, and we get 2.45, which is this, equals half g is 9.81 multiplied by this, which is t plus 0.25. We will cross multiply. 2.45 multiplied by 2 will be 4.90 into 9.81 times t plus 0.25 So t plus 0.25 equals 4.90 by 9.81, which will be zero point 0.5. So t will be zero point 0.5 minus 0.25, which will be 0.25 seconds. To cross the height h, the stone will take 0.25 seconds. Now we will substitute the value of t, which is 0.25 seconds, in this equation. H is equal to half gt square, and find the height. So we have h equals half g, which is 9.81, multiplied by t, which is 0.25 square. This will give us height from which the ball fell to be 3.06 meter. Let's see the next problem. A ball is dropped from the top of a tower 30-meter high. At the same instant, a second ball is thrown upwards from the ground with initial velocity of 15 meter per second. We have to find, number 1, when will they cross each other? Now this ball is dropped from the top of a tower. Suppose this is the tower. The ball is moving downwards, so its acceleration a will be plus g. Its initial velocity will be 0. At the same instant, another ball is thrown upwards with initial velocity 15 meter per second. Since the ball is moving up, its acceleration a will be minus g. Now we have to find when will they cross each other. Suppose the second ball travels height h before it crosses the first ball, so that the distance traveled by the first ball before it crosses the second ball will be 30 minus h, because the height of the tower is 30. We have to find the time t after which the two balls will cross each other. Now since we have, for the first ball, its initial velocity, its acceleration, the height through which it falls down, we can find the time with the help of the second kinematic equation, which is displacement s equals ut plus half at square. That will be, since initial velocity is 0, ut will be 0, and half gt square, replacing a by g. The displacement of the first ball is 30 minus h. So we write for s 30 minus h. So this is for the first ball. For the second ball, we write s is equal to ut plus half at square, which will be ut minus half gt square. For upward motion, we replace a by minus g and s by h. Initial velocity of the first ball is 15, so we write h equals 15t minus half gt square. Since half gt square is 30 minus h, so we will substitute for this half gt square minus 30 minus h. So that will be 15t minus 30 plus h. This h cancels with this h and we get 15t equals 30 or t equals, that is 2 seconds. So the two balls will cross each other after 2 seconds. In the second question, we have to find where will they cross each other. That means we have to find the height h. So for that we will substitute the value of t here and write 30 minus h equals half. G is 9.81, t is 2 square, so it will be 2 multiplied by 9.81. So h will be 30 minus 19.62, which gives us height where the two balls cross each other h as 10.38 meter. Next problem is a stone is dropped into a well is heard to strike the water in 4 seconds. Find the depth of the water level, assuming velocity of sound in air to be 335 meter per second. A stone is dropped. This is the stone which is dropped. It is moving downwards. Its initial velocity u is 0. It will strike the water, create a sound, and the sound will travel in upward direction and cross the height of the water level h. So since the stone is moving downwards, its acceleration will be plus g, and since the sound is moving upwards, its acceleration will be minus g. Suppose the time required for the stone to travel the height h is t1, and that required for the sound to travel upwards be t2, and we are given t1 plus t2 to be 4 seconds. So for the downward motion of the stone, we will use second kinematic equation, which is s equals ut plus half at square, which will be h equals ut1, which is the time required for the stone to cross distance h, plus half g. We replace this a by plus g because the motion is downwards, and t by t1. Since the initial velocity is 0, we get h equals half g t1 square. So we name this equation as 1. Now we will consider the upward motion of the sound. We know height will be equal to speed, that is distance is equal to speed multiplied by time. Speed of sound is 335 meter per second multiplied by the time required for sound is t2. We name this equation 2. Now from equation 1 and 2 we write the value of h as 335 t2 equals half g t1 square. In place of t2 we will write 4 minus t1. From this equation t1 plus t2 equals 4. So we get 335 into 4 minus t1 equals g by 2 t1 square, which after simplification gives us a quadratic equation t1 square minus 68.3 t1 minus 273.19 equals 0. This is a quadratic equation in t1 which we can solve by using quadratic formula t1 equals minus b plus minus b square minus 4ac upon 2a. By solving this quadratic equation we will get t1 equals 3.79 seconds, which is the time required by the stone to travel distance h and to strike the water. Now in order to find the height of the water level, we will substitute the value of t1 and g in this first equation. We will get h equals half, g is 9.81, t is 3.79 whole square, which after calculation gives us height of the water level to be 70.44 meter. So this is the answer. Friends, if you like this video, please click the like button. Share this video with your classmates. Subscribe this channel to get more videos of this type. See you in the next video. Until then, keep watching Number Collage. Thank you.